I'm very honored to present the biannual Fishman Fund Fellowship, which offers an exceptional Sanford Burnham Previs postdoc, a 2-year award. This fellowship demonstrates the Institute's strong commitment and support to the future leaders and pioneers of science. Today, I am so pleased to introduce Dr. James Marchant, PhD. He's a postdoctoral associate in Dr. Alex Colas' lab. His research focuses on developing a gene therapy to treat heart failure. Heart attacks reduce blood and oxygen flow to the heart muscle, leading to scar tissue that can increase the risk of future heart attacks. Dr. Marchant aims to convert cells within the scar tissue back into healthy muscle heart cells. Wow. Please, Dr. Marchant.
Thank you, Arlene, for the kind introduction, and thank you all for being here today. My name is James Marchant, and I'm the proud recipient of the Fishman Fund Fellowship. I would like to start by expressing my sincere gratitude to the Fishman Fund founders for their donations and their generosity. Your contribution extends far beyond a simple award. This is your contribution to science, your contribution to the scientific discovery, and your contribution to developing treatments and supporting young scientists in their research and their career development. For this, I want to thank you for myself, but also on behalf of my co-recipients, as well as previous recipients and future recipients. Your donation means more than you can imagine. As good science is never done alone, I would like to also extend my gratitude to my fantastic lab members and my outstanding mentor, Dr. Alexandre Colas, without whom I would not be where I am today. At 8 years of age, my closest childhood friend and I were staring into my aquarium filled with tropical fish. In that moment, I decided I wanted to become a marine biologist. A few years later, my family and I immigrated from the United Kingdom to France, where I was faced with learning a new language, navigating a new education system, and integrating into a whole new society. My dream of becoming a marine biologist seemed to be slipping away. However, being the self-driven, determined, and sometimes stubborn person I can be, I became fluent in French. I obtained my master's degree in marine biology, and I fully integrated it into French society. So, why am I standing here today in front of you all, speaking English and not French? Why San Diego and not Paris? What happened to that childhood dream of mine? Well, during my master's degree, I was introduced to cardiac cells. Cardiac cells, which are literally the beating life of life itself, entered into my academic path and changed my career trajectory. I was fascinated with how cardiac cells are electrically activated to contract in a beautifully orchestrated manner to pump blood around the body. The more I learned about cardiac cells, the more infatuated I became, and the more curious I became to learn about how they work. The downside, of course, of this is that I also learned how sometimes they don't work, how cardiac diseases occur, and how devastating an effect they can have on patients and their families. In turn, this helped me to better understand my uncle. You see, my uncle was diagnosed with heart failure around the same time I was dreaming of becoming a marine biologist. By the time my family moved to France, he was on the heart transplantation list. By the time I earned my master's degree, he had been waiting on that list for 6 years. He died 2 years ago, waiting on that heart transplant list for such a long time. But what if there was no heart transplant waiting list? Instead of a heart transplant being the only treatment option for patients with heart failure, what if we could regenerate the failing heart? What if we could take the scar tissue that is causing the disease and turn it back into healthy beating tissue? This is the goal of my research, to convert damaged and injured cells back into beating cells by delivering potent cardiac gene signals that initiate a fundamental change in the cell properties. We are essentially reprogramming the cells. By introducing these signals, the cells will initiate a process transforming them from non-cardiac cells back into cardiac muscle cells. This process is not easy, and there are a number of molecular barriers to overcome. The aim of my project is to overcome these barriers to develop a heart failure therapy. And using this approach, I have already achieved a reprogramming efficiency that is 4 times higher than the current industry gold standard. This preliminary data is very exciting and shows true promise for developing the foundation of the first heart failure therapy, and I very much look forward to sharing my progress and results with you throughout this fellowship. This project and fellowship will support my efforts towards achieving my career goal of leading my own team in translational medicine, conducting research to develop therapies to treat cardiac diseases and arrhythmias. I'm standing here today not as a marine biologist, but as the recipient of the Fishman Fund Fellowship, and I can confirm with pride and certainty that my childhood dream did in fact come true, as I am making significant contributions to a scientific field that is close to my heart, and I thank you for making this possible. I may have set out to be a marine biologist, but I can visit the aquarium whenever I want. I thank you for your attention, and thank you one last time for your generosity, for your contribution to my science, to this project, and to my career. Thank you.